Coming up this month on American Heat, key players in the fight against the Los Angeles wildland fires give us an insider's perspective on the conflagration. The worst train wreck in Amtrak's history occurs near Mobile, Alabama, when the Sunset Limited passenger train careens off a damaged bridge into a remote bayou. In Hot Topics, Captain John Ryskowski of the Reno, Nevada Fire Department describes some essential elements of an effective pre-plan for railroad incidents. Windshield cutters are put to the test when Firefile begins a three-part mini-series on new vehicle extrication tools. Dr. Bill Kramer of the University of Cincinnati brings you this month's college questions. And survival training kicks off a new basic level training series with a look at personal protective clothing. Lessons learned by the people involved coming up right now on American Heat. Hello and welcome to our program. I'm Larry Estempa. Last fall, the entire nation watched as thousands of firefighters battled the wildland fires that ravaged Southern California. The effect this disaster had on the area is still being measured, but how does it affect the rest of the nation? And what lessons can we learn from those who were involved in the fight? This month, in our follow-up report, we asked a few of the key players to discuss some of the important issues raised by the disaster and the lessons they may have learned.
Fire started about 20 minutes to 4 on the morning of October 27th, 1993. Fire, the origin of it was a campfire. We had a transient, an illegal immigrant who was up there, and being from the tropics, he had no idea that we have a Mediterranean climate with high winds and very combustible vegetation. So the campfire he lit immediately burned out of control. County Fire Department was notified. The fire started in their jurisdiction, and being a mutual aid partner, we also responded to the fire around 4 in the morning. By 5 o'clock, we had a full set of firefighters from both agencies attacking a fire that was approximately 30 acres in size. Now, the origin of the fire was up just beyond those 3 transmission towers you see up there. And we were trying to hold the fire above the road. But at approximately 5 o'clock in the morning, high winds came up, and we had to evacuate the firefighters off the fire line. By the time those firefighters from up on that road system got to this location, which was the original incident command post, the fire was here, and a structure was already on fire right on this street, Altadena Drive. At that point in time, the fire is now a 3-jurisdictional fire. Remember, it started at 20 minutes to 4. It's now 5:30 in the morning, and it's burning in the Angeles National Forest, Los Angeles County, and the city of Pasadena. Within 4 other hours, when they had passed, we had a 4th jurisdiction involved. The fire had spread as far east as the city of Sierra Madre. And by 10 o'clock in the morning, this fire is probably 3,000 acres in size already. So, brief chronology, 30 acres in size at 5:15, 300 acres in size at 5:30, and 3,000 acres in size by 10:30 in the morning.
Never before has a conflagration made such a huge demand on the resources of the fire service. 2 days after it began, 6 counties came under a presidential declaration. Before the fires could be controlled, 1,241 structures were destroyed. Estimated damages totaled $500 million, affecting 197,225 acres. The cost of the firefight, $60 to $100 million. Fighting these fires demanded an all-out assault be waged by every agency, individual, apparatus, and resource, and commanding these resources was a monumental task.
If the fire involves 2 or more jurisdictions, we will set up what we call unified command, where representatives, commanders from each jurisdiction join together. They develop an incident action plan, and they work in conjunction with one another so that there is unified command and unified plan of action to contend with the incident. We usually will set up an operations chief who is responsible for the actual firefighting. We have logistics and planning, because these types of fire situations have a lot of needs for planning, keeping track of resources that come in, resources that are assigned, the logistics, the feeding, just supporting that many personnel. The Altadena fire, we had 3,000 people. The next week, the Malibu fire, we had, at the height of the activity, close to 7,000 firefighters and support personnel. It was a major utilization of the mutual aid system. And it's like anything else, is that when the system is used to a great extent, we learn things, we get the experience, we get better at it. It was used heavily in '91 with the unrest, and then with the firestorms in '93, again, major utilization of the mutual aid system within the state of California. And I think that because of what we learned and what we did in '91, we were better able to do it smoother and more effectively in '93.
The Malibu fire was the largest mobilization effort in California history, and the figures are staggering. 438 agencies participated, including 915 engine companies, over 7,000 personnel, 15 helicopters, and 11 fixed-wing aircraft. John Bryant, Assistant Director of Operations for the United States Forest Service, describes the mobilization effort.
We establish a mobilization site in order to ensure that they have NOMEX and tools. Every agency works a little different. In our case, our agency, at a base, we establish, on the fire at a base, we establish a logistic support where we provide tools, equipment, and all that. Most fire departments don't do that. So in some cases, you would have a crew coming in that didn't have tools and no way to equip them. So we were delayed in putting the tools onto the site. This is not only interagency, it's interchange. The way you suppress these wildland fires in the urban interface is it's a combination between the urban firemen, the wildland firemen, together working to do the best of their skills to do the effort to suppress the fire. In our case, the city structure engines, 1,200-gallon pump units, pumpers that were what we call a Type 1 engine or a Type 2 engine, where with our tied in and joined with our Type 3 engines, which are wildland engines, which carry about 300 gallons of water, 300 to 500 gallons of water. We happened to carry foam, which was very effective, and the municipal fire departments had large volumes of water, so they took onto the hydrant. We put the foam in, and it would basically hold on to the fire. Most of the engines that arrived in Southern California were foam equipped, and the combination between the urban fire department and the wildland agencies, we were able to work together, foam the house, and pick it up the spots that did catch with the heavy water from the other side. So that was one technique we learned.
Within our department, what we would like to do is we've begun a program to put Class A foam capability on our engine companies. We want to retrofit many of our engine companies with the Class A foam. We've had good effect ourselves where that's available. We've worked pretty closely with the Forest Service units that have Class A foam, and we think that's a real positive improvement. And that's something that we've put a high priority on. And we feel that it helps in protecting structures, that we can pre-treat a structure that is going to be threatened by the fire, and we think that's a real positive.
We're at a place now known as Zane Gray Terrace at an interface section along the foothill. The Kenaloa fire, when it crossed Eaton Canyon, began burning aggressively to the west through all the residential areas here through Zane Gray. The fire actually beat the firefighters into this area. During that time, we were running mutual aid and mutual jurisdiction with Los Angeles County. There were 12 Forest Service engines and approximately 30 Los Angeles County engines at that time that were leapfrogging each other, trying to stay ahead of the fire. The fire beat us into Zane Gray Terrace, and we weren't able to do our normal structure protection in this area. This is one of the casualties that happened by not being able to get established into an area soon enough. This house was already on fire when we arrived on scene. We were able to save the house that's off to the left here because we were able to get set up in structure protection mode and do some foam work and do some clearance around that houses. We used an awful lot of foam in this area. We secured houses as quickly as we could, and then we moved on. The fire was at this time still moving off to the west on us. So the best we could do was secure a residence, become available, and then turn ourselves over to the incident commander for reassignment onto to another section of the fire.
Okay, while fighting the Kenaloa fire, I really came to realize just how important communications are. Now, in all of our Forest Service trucks in the Angeles National Forest, we have both Forest Service and LA County Fire Department radios. And most of the LA County Fire Department engines and vehicles also have the Forest Service radios. So that's how we normally communicate on a fire, is with our radios. But once we had hundreds of firefighters and eventually thousands of firefighters, the radio system became inadequate. Throughout this incident, during critical times, the operations section chief, Dave Kerr, would call me on my cellular phone. He couldn't get through on the radio. There was too much radio traffic. And so we were able to successfully communicate on this phone. For example, at one point in the incident, he had an emergency need for 2 helicopters. I did not answer the radio when he called me, but he instantly got through on the telephone. Another thing that I found to be very helpful with communications on the incident were these text pagers that most of the firefighters on the Angeles National Forest have. Throughout the incident, when the dispatcher or the chief were unable to get a hold of me, I received messages on my text pager. I also received messages on this pager telling me what resources would be arriving to help me and when they would arrive. And so I felt communications ran very well in a highly complex incident, and I really felt that was one of the critical factors in not losing more homes.
The critical role that careful management played in the firefight cannot be stressed enough. From the initial mobilization to agency interchange to new attack techniques to state-of-the-art communications, risks were assessed and precautions were taken to minimize the dangers to responders and civilians in the heat of the battle. But what about the future? Can anything be done to pre-plan for incidents of this magnitude?
As the fire was burning, we had the fire history maps available to us, and many of the veterans and people that had experienced fires in that area before could pretty well tell where the fire was going to go, where we would have a chance maybe to stop it, and so forth. Our pre-planning also really began the day before the Malibu fire. Because of the predicted weather conditions and so forth, we went ahead and hired back about 100 personnel. We staffed up some of our reserve rigs. We staffed up a lot of our companies in and around the urban interface, the brush areas, to beef up the staffing.
Last March, the Forest Service burned 100 acres right on top of that ridge where you see the power lines. And we had assistance from our friends in the Los Angeles County Fire Department. Now, this area had been burned intentionally in a prescribed burn. So the two agencies working together on Forest Service land burned 100 acres on that ridge top, and just about the time the winds died, the fire tried to cross that ridge. But the prescribed burn that we had done the previous spring stopped the fire in that location. And so that's a real lesson for us as land managers. You have to properly manage the vegetation. By having a pre-planned area to stop this fire, complete with the burned out area, it was not only safe to put the firefighters up there, but we were effective in setting back fires and stopping the spread of the main fire.
As always, events of this magnitude draw a lot of attention from the media. Pre-planning with the media will not only make your job easier, but may also help protect their safety on the fire ground.
The media's involvement on these fires is a safety problem. Very few reporters have the proper Nomex fire clothing that should be worn when you're out here on an urban interface or a wildland fire. And because the news media has rights, they tend not to coordinate with us and go directly to where some of the action is. And we've had cases of media being trapped in California in the fire. And it's up to people like me to manage that situation. I try and get the media to report to the incident command post, and we'll issue them the firefighter clothing that they should wear when they accompany us out to the burn. But the big problem is getting the news media to do that.
The media is the eyes and ears of the public. And the fire service needs to provide information to the media that's beneficial to the public and beneficial to the fire service. We need to use the scenes of wood roof shingles burning presented back with the explanation of what that's causing. We need to show that the brushing against a house is causing us to have to try to hold that house or put extra effort to hold that house. The narrow roads, just need to have people that are cognizant of that problem in order to present it to the media, who then present it to the public, and then in turn it comes back to the Planning Commission that says, hey, no more are you going to build that curvy road. You're going to build a good, wide road for access.
When dealing with the media, be sure you have a lot of knowledge at your fingertips. Talk in simple terms, since most people do not understand the fire service lingo. Also, be ready for the inconvenience. The media will come at their own time frame, and you may have to work them into your schedule and still meet your responsibilities.
There are are a lot of lessons we learned in fighting the Kinaloa fire, and probably the most important one we've learned here for the last 30 years, and that's the value of the incident command system. A pre-planned management structure where all agencies can work together. It doesn't matter whether we're here in the Angeles National Forest with our extremely steep ground and hazardous brush, or we're fighting grass fires in South Dakota. It doesn't matter one bit. This system is effective wherever you use it. And we use it not just for fighting wildland fires, but earthquakes. We've dealt with those, floods, typhoons, hurricanes. We use ICS on all these things, and firefighters everywhere should be using it. A couple other things of interest that occurred on this fire was the success that the Forest Service in particular had using Class A wildland foam. We were able to aggressively fight this fire because of our foam. Normally you could suppress a piece of fire or knock a fire down on a house and not have to go back. The foam is very effective and stays effective for a long time. So with all of our engines having foam on board, they were very effective. Lastly, something that we learned in our jurisdiction is don't be afraid to mix in other kinds of firefighters with your engine personnel. Some of our Forest Service hotshot crews, which build your hand lines, were not effective in their original mission. The wind was blowing too hard to even construct fire line. And so they were mixed in with the Forest Service engines and helped blade fire hose and made us a more effective structure protection force.
Look to see what could happen in your community, whether it be a 747 airliner making a forced landing nearby, or a crash, or a train derailment, hazardous materials, whatever. Look at your risk. Do a complete and total risk assessment. Then look at your resources and see what preparations you've made, what pre-planning may be necessary, and definitely look at your mutual aid situation. And anything that can be taken from our experiences here, from our mutual aid system, from the incident command system, take that and apply it to their own community.
One of the points brought out by the Southern California firefighters was the role that protective clothing played in the firefight. Later on survival training, we'll examine the NFPA regulations affecting personal protective gear. We'll show you how to choose the proper clothing and how to wear and care for these garments. Our second incident this month occurred in a remote bayou 10 miles north of Mobile, Alabama. Lost in the early morning darkness, a barge took a wrong turn and struck an 87-year-old railroad bridge, setting the stage for the worst rail disaster in Amtrak history. 12 minutes later, the Sunset Limited passenger train careened off the bridge, killing 47 people, injuring 126.
The crew of the MV Mauville radioed the Coast Guard in the pre-dawn hours to report that part of its tow had gotten loose. 12 minutes later, they radioed again to report there had been a train wreck. Some 26 minutes later, dispatchers answering 911 calls remained frustrated in their attempts to determine the exact location and scope of the disaster.
Yes, listen, this is Amtrak train supervisor. We're on the Mobile River. The bridge is going on. We got cars burning, people in the river. Can't swim. We need help. Any kind of help you can get down here.
Stay on the line with me, sir.
Yes.
Okay, you with the Amtrak train?
Yes, ma'am. I'm the supervisor on board. We're on the Mobile River.
You on the Mobile River?
On the Mobile River. We got cars burning. They're over the bridges out. There's people in the water. We're trying to help them. We need all kind of help. Yes, ma'am. We need help. Help, please.
Okay, just stay on the line, okay?
Oh, sure.
So we got someone en route to you. It has been called in before, but I need you to stay on the line, okay? Amtrak train. Amtrak. Hello, sir.
Yes, ma'am.
Just hold on the line, okay?
Yes, ma'am.
Give me some information on where this train was coming from.
Coming from New Orleans, sir.
New Orleans?
Careful, watch yourself. It's left New Orleans. Ma'am, I have to go and assist these folks.
Okay, sir.
All right, then.
The wreck couldn't have happened in a more remote area. The location was completely inaccessible by road. The only way in was by boat, air, or by the same tracks used by the Sunset Limited.
CSX, who apparently maintains the railroad service in this area, had put together a train which included one engine and 4 cars. We made a staging point at the train itself that they had brought up, which was located in front of Scott Paper Company. There we loaded up the various equipment that was needed, medical equipment, fire suppression, support equipment such as lights and generators. It was approximately about a 30-minute ride up to the scene.
While engine companies, ladder companies, and medics loaded their gear on the train, fireboats and other vessels were making their way through the darkness to get to the scene.
When we rounded the bend, you know, coming into the bayou, we could see some flame, we could see some glow that, you know, we could tell we had a fire, of course, which they had already telling us on the radio that we had a fire. Okay, our main thing, our main objective at that time was to search for survivors and try to rescue anybody that we could. When we came in and came up on the scene, we had 2 large tugboats that was in the area. Of course, they moved over to the side. The captain was talking to them on the radio, and they was getting information from them. We had 2 or 3 small skiffs that was going around in the bayou, checking, looking for survivors, anybody in the water or anything of that nature. We searched it for about 20 minutes. We didn't even start any firefighting operations for about 20 minutes.
As rescuers searched the waters for survivors, responders arriving by rail from the Scott Paper Company were determining their strategy.
You know, on our ride up, each company we were planning what we were going to do when we got there. And we're on ladder company, so our job was we're going to set up lights because we were going to take the walking engine to the rear car, and the front car was going to be our critical energy patient. So that was our first job when we got off, was set up the lights so we could see, because it was a high embankment. It was about 5 feet of track bed level, and then it slanted off deep down in the swamp. So when we first got there, with all the masked people, we kind of got split up. You know, the crew, me and Mark wound up together, and Captain Black and another private, they went on to the wreckage site. And so they had already stretched some hand lines. So they had already made it to the fireboat and stretched some hand lines by the time me and Mark got to the west bank.
The engines that were off to the west side of the bridge were fully involved in flame. There was diesel coming out of them. There was a baggage car that was burning. There was another coach crew car that was burning. We had our air packs on, but we wouldn't have been able to gain access with our air packs. We couldn't get in. The openings were I'm a small stature. A 200-pound man wouldn't have been able to get in there. A man my size wouldn't have made it with an air pack on his back. We didn't want to get into anything we couldn't get out of. We had done the best job we could visually. We had looked through the cars, the intensity of the heat, the smoke, the fumes, the stability of the vehicles that were in the water. Were they going to stay in that position? Were they going to roll? It was all a touch-and-go situation. And when you go into a rescue scene, your primary concern is your own safety and the safety of your crew. If there's life jeopardy, if there's a hope, the risk factors involved, you assume for yourself, is it going to be worth the risk? Would you put yourself on a limb? Naturally, we'd do it, but at the time, there was really no hope for any survivors in the water at that time.
One of the first things I saw when we come up on that first car, there was I'll never forget, there was a child's handprints on the window from where it just smoked up from the smoke from the other car that was burning, had smutted up the windows, and there was 2 handprints on the window.
We pulled a 2-inch line off the fireboat. We had capabilities of handling, with one man and myself, approximately 250 gallons of water off of a nozzle. It's got quite a bit of pressure on it. We're standing inside of a burning car. The water, the heat, it's slippery. There's 2 of us there. The fireboat's nudged up against the car we're in. We had a bass boat sitting right there with us. We had the fire under control, but that after learning of the capacity of the fuel tanks, you're talking 250 gallons of water versus 2,000 gallons of diesel. The intensity of the heat in that one engine that was rolling, the diesel was going to ignite as soon as it touched the water. So we didn't know if it was going to flow away from it. Was it going to contain itself? How large was the leak? We realized when we hit it, we couldn't put it out, that all we were doing was aggravating the situation. We could have put foam on it, then would have been into a big concern with the environmental pollution, because if we'd have put that fire out, later to find out there's over 5,000 gallons of diesel. All that diesel fuel was going to be involved in that area immediately around us. We felt that it was at that time best to leave that area concentrated, let that diesel burn itself off.
As I got off the train, you could see the engines on the other side of the bank of the river that were still on fire. The fire department fireboat was already applying, water on the fire itself, but it was still fire showing. There were a great number of people that were sitting on the track. Some were standing, some were actually had taken mattresses, lied them on the side of the tracks, and were lying down, just pretty much resting, I guess, and waiting for someone to come and take them back.
When they illuminated the area, there was 100 or so people kneeling, laying, standing up and down the track for a couple hundred feet. And we asked that they stand up and proceed toward the train, and they did. Everyone got up. There was no one left behind. I didn't notice any injuries per se right there, with the exception there's some people in shock. Some of them were cold, but they were all mobile, and they all headed to the train for medical assistance.
It was kind of spooky because they were coming out of the edge of that dark into the lights, and a lot of them had sheets and blankets wrapped on them, and real quiet. And most of them, no injured. There were two ladies that we carried to the train because their feet, they were barefoot. They didn't have any shoes on, and the rocks were hurting their feet. And we carried them to the train, put them on the train. And other than those two ladies, everybody seemed to be in great shape.
People using whatever they had available to put on their feet. It's one thing we noticed. They had pillowcases wrapped around them, blankets, napkins, anything they could find to try to cushion their feet from the rocks, because as Tommy stated, the bankment was pretty steep.
They were triaged back at the Scott Paper at our command post. I'd set up the triage area right along the side of the tracks. It was approximately, I think, about 6 miles down the track from the actual accident site. The initial responders, I gave the orders to them to more or less do a quick triage. If they had to, open airways, do everything they could to get the patients loaded and back down to us where we could more stabilize them and send them out, since we was unable to get any kind of ambulances or aeromedical helicopters into the scene.
There were other medics that were called from their stations that were on duty, as well as off-duty personnel that had been called and were waiting at the triage areas to take over my patients. I offloaded my one ALS patient who had settled some, and our treatment had worked well for her. She was calmed, and I think some of it possibly was stress-related. She was offloaded first, as well as two children that were with their parents, and then the rest I offloaded by car. They were all ambulatory. They got up and walked on their own, and pretty much, other than some minor scrapes and bruises, stress-related injuries.
I guess 7:45, 8 o'clock that morning, my on-duty triage officer, Stanley Vincent, called me on the radio and advised me that there were no more. This was after the second train of rescue personnel and extrication equipment went to the scene. He called me on the radio and advised me we did not have any treatable victims left, and then he also advised me the approximate number of body bags he would need for the fatalities.
From that point on, it wasn't very pleasant. We wound up on the temporary morgue barge that they set up there. When daylight hit and the divers got there, the only thing left to do was retrieve bodies, which we're not set up to do.
There were 47 people who perished in the accident. Of the 285 that survived the incident, 126 were injured. At the time of this taping, 23 of the survivors were appearing before a National Transportation Safety Board hearing to try to shed some light on the accident.
I was jolted awake by an impact. The train hitting the water. I was thrown up against the two seats directly in front of me, and I went to the floor, and I waited approximately 10 or 15 seconds for the train to stop. There was just a violent shaking and rumbling, and I knew there was a derailment.
Just because of the impact, the engineers were at least out of service.
So I was yelling Mayday, Mayday, Mayday into the radio as I proceeded through the dining car and through the observation car. I was checking the observation car for any passengers that might have been located in the observation car at the time.
For the passengers of the Sunset Limited, the memories of September 22nd will always be with them. Those same memories will remain with the responders from the Mobile Fire Department for a very long time.
When we come back, Ron Moore will demonstrate some new vehicle extrication tools, and Dr. Bill Kramer will join us for this month's college questions. All that and more coming up next in Second Alarm.
At any moment, you may be called upon to fiercely defend the lives of those stricken by disaster. The greatest weapon you can take into battle is the training you received long before the firefight. In 1994, all survival training segments on American Heat will focus on specially selected firefighter training topics, such as firefighter safety, protective clothing, breathing apparatus, ladders, forcible entry, structural search and rescue basics, basic vehicle rescue practices, and more. Look for survival training every month only on American Heat.
The Sunset Limited last September is a stark reminder to all of us that disaster can strike anywhere railroad tracks can be found. Because railroads have the greatest hazard potential of all transportation systems, fire departments must be aware of the railroad operations in their area. In this month's Hot Topics, Captain John Ryskowski of the Reno, Nevada Fire Department and Northern Area Coordinator of Nevada Operation Lifesaver described some essential elements to an effective pre-plan for railroad incidents. John?
Thanks, Larry. Welcome to Hot Topics. I'm John Ryskowski from the Reno, Nevada Fire Department. Today we're down here in Oakland, California along the Southern Pacific Main Line at the Amtrak facility. Amtrak uses American railroads to haul passengers all over the United States. We're going to find out if Amtrak comes through our area, find out if they run on the tracks through our area. Amtrak uses other railroads' tracks to move passengers through different areas in the country. We also want to find out what type of operations are on here. Southern Pacific is a Class 1 operation. There's also regional short lines, there's tourist, and there's also high-density commuter operations. Those are all things we need to know about. I guess the bottom line here is know your first-in district. Know your first-in district. Want to find out what's going on. Does Amtrak come through our area? What times do they come through? Get out there and find out. Also, too, we want to find out how the railroad divides up the different railroad tracks that are all over the country. They do that by mileposts. They also use different geographic locations that may be very different than what we're accustomed to. The railroads were here first, back in the early 1800s. They gave different names off of old railroad officials or certain locations, control points. Those names could be very different than what we have on our maps. The public names for places and railroad names could be very different. We need to find that out. Also, get to know your crossings. Find out what crossings in your area. The last major Amtrak accident was at a crossing. Those crossings are potential hazards within our district. We're going to find out where they are and what they're called. Because when we talk to the dispatcher could be located 1,000 miles away. He's not familiar with your district. You got to know where you are on the railroad tracks so you can interact with the railroads and be effective first responders. But basically, the bottom line is here, know your first-in district. As we get to know the tracks in our area, we'll want to color code them or identify them with certain features on our maps so we know what we've got in our districts. Also, we want to find out the access, how we're going to get to those tracks. Tracks can have extremely limited access. During the Sunset Limited accident, the only access to the accident scene was by rail. It's kind of like, how can we get there from here? Also, find out about the railroad's emergency plans. Amtrak and your local railroads, tourist operations, commuter operations, and regional short lines have developed contingency plans of what they're going to do in case of a derailment or an accident. Get to know those plans. Become part of those plans. Meet with the railroad professionals. Find out what they're doing in your area. Also, tourist railroads, by certain state mandates, will have complete plans that'll mark off all the spots along their railroad tracks and what's going on. We can find out access points and stuff. Major carriers, Class 1 railroads, stuff like that, will also have contingency plans. We need to become part of those plans. We also need to get numbers. How do we get in touch with these railroads, and how do we get to meet our railroad professionals? Find out what rail operations are specific to our areas. Find out the timetables, the schedules. Find out when those railroads operate. Some dinner trains only operate at certain times, weekends, evening hours, all different times of the day and night. Railroads are a 24-hour operation. Also, commuter operations have very high density loads certain times of the day, then can go to a limited operation. Those are things we all need to know. Also, tourist operations can have certain EMS problems that we want to be aware of. The tourist industry is a growing industry within the United States. We have a lot of older retired people that ride these trains. These are things that we want to know. They can present us with some unique EMS problems. Also, rail fan trips, steam engines, and different things that will come into your area that will bring a large influx of people. Those are all things we want to follow, kind of find out what's happening. Also, Santa Claus trains, special operations during certain times of the year, we can get into those things. We want to find out what's going on. They all present unique problems. Again, the bottom line is, know your first-in district. Amtrak uses 3,000 horsepower diesel-electric locomotives. Newer high-tech locomotives are coming that are up to 4,000 horsepower. Also, we may have a change in fuels. Currently, we're using diesel, but there are alternate fuels being looked at to lower emissions. Those are LNG, so they're going to have a whole other different types of problems that we may have to become aware of. Also, some areas of the country have electric locomotives that use power that's derived from overhead catenary. This can be 25 to 50 kVW, 60 megahertz. A typical diesel-electric locomotive has peak voltages of 1,400 volt systems, and the average voltage is 600 volts. That's how the safety warning signs on the side of the locomotives will reflect to. But you do get those high peaks. Also, you have large onboard batteries that supply current to the 72 volt system that runs the associated systems on the locomotive. Also, many tourist operations use steam engines. Those too can provide us with unique and special hazards and different operating problems. Current Amtrak equipment and power uses what they call head-end power, or HELP. This power is provided by the locomotive or by a separate power car with onboard diesel generators. This is a 480 three-phase power carried in cables that connect between each car. This provides all the power for all the systems, air conditioning, and different operations lights on board those cars. This is something we want to think about when we're working around these cars, is the electrical system. Older tourist operations still use the old steam lines. Those cars can have batteries. They can also have small generators that will provide lighting and stuff like that. That's the difference between current equipment. That's also something that we need to be aware of. We need to be able to identify those features when we get around these cars. Also, the brakes on these cars is provided by air, which is within hoses and stuff, air provided by the locomotive that provides the braking. Also, we have handbrakes on these cars. We want to make sure those applied and make sure we have safety features activated when we get around this equipment. Several types of passenger equipment is in service today. We have the older heavyweight equipment, which was from heavy plate steel, riveted construction. Some of those cars even had concrete poured in the floors. What that was is to give them a heavy weight so they'll ride really very well. Then we went into the post-World War II era, where we went into what they call the lightweight equipment, which is cars with the fluted sides. That was kind of symbolic of the streamline era. With those cars, the riding qualities came from the trucks instead of the weight of the cars. Different types of construction, and they called them a lightweight, but really they're not really lightweight. They're still extremely heavy cars. Current Amtrak cars, they have several different types of cars. They have the Heritage Fleet, the Superliner, the Amtrak. These are all different styles of cars. Also, some of the newer cars, the double-deck Superliner cars, Superliner 2 cars, they have interior alarm systems and different designs that we might want to become aware of. Also, they're going to have different interior configurations. They're going to have coaches, sleeping cars, diners, lounge cars. Those are all things that we need to know if we have to get into those cars in very unusual situations. During normal operations, access to the car is through these walkways. They can be located at the end of the cars, or they can be located in the middle of the cars, depending upon the configuration and the design of that car. During abnormal conditions or during a derailment, we want to have alternate points to get into those cars. We can pop off the windows. The windows are designed to be removed. Information on that, on how to open those windows, is located on the ends of the cars. We can go to specific windows on the cars. That information will be provided right here, and that'll let us know which windows are removable. Let's talk about railcar construction. We got some serious weight here. This is a typical truck assembly off of a passenger car. This can weigh 12,000 pounds. Diesel locomotives can weigh 250,000 pounds. Some rail cars hit 360,000 pounds loaded. Got some serious weight here. How are we going to handle that serious weight? We may need specialized equipment. Some of the rescue and extrication equipment that we carry on fire trucks might not be adequate to handle these types of weights. We may want to rethink what we have to do in a rescue situation. We may need oxyacetylene equipment. We may need K-12s. So that's something that we all have to address. Also, the construction of the cars. The newer cars, as the Bombardier cars and some of the Horizon cars, have aluminum construction, stainless steel, steel underframes. Back again to those heavyweight cars, we got heavy plate steel. All enter into the program, all enter into our rescue needs and our rescue concerns when we go to a derailment. In this segment, we briefly touched on the high points that we need to know as first responders about railroad operations. We need to go out and meet with the railroad professionals, both from Amtrak, also from Class 1 railroads, tourist operations, commuter operations, short lines. They're our best resource. They can give us all that information that we need to know. They can keep us abreast of all the changes. There are changes. Changes in passenger operations are happening daily, just as in freight operations. High-speed trains, 200-mile-an-hour trains, are under consideration in this country. These are all things we need to keep up with. Travel by rail is growing. Commuter rail is also growing. More and more people are coming off the highways onto the rail. In closing, we need to know our first-in district.
For more information on this topic, call Captain John Richkowski at the Reno Fire Department at area code 702-334-2300.
New products for the fire service hit the market every day. Some are useful, some aren't. Aside from testing these products in the field yourself, how can you determine if they really work? This month on Fire File, American Heat begins a 3-part mini-series on new extrication products. In Part 1, 2 different brands of windshield cutters are put to the test. Ron Moore, American Heat's Director of Education, tries them out and gives you his initial impressions.
Next 3 editions of American Heat, through our manufacturer showcase, we're going to take a look at a couple of new tools or some new technology you should be aware of. We'll be looking at windshield saws. I have two models, two competitors to show you. We're going to look at a tool called the Column Master, which is kind of a mechanical system to be used with a come-along for moving steering columns. And then finally, we'll take a look at a new device called the Ram Jammer, which is something a lot of us have been doing on a homemade basis for quite a while. Now we have a company out there that's actually making a good, legitimate model. So we're going to take a look at these three types of tools over the next three editions. This month I want to start out looking at some examples of windshield saws. Now what happens in the technology of vehicle extrication, we've gone away from the old days of chopping with a fire axe, wildly chopping down through the windshield glass to try to get the windshield removed, and the age of the windshield saw is here. I have two actual saws to work with today, and we're going to talk about the windshield glass removal technique and how they could be done best with the saws. Let's take a look at the windshield again. It's the double layers of glass, and on the newest cars, it's 2 layers of glass and 2 layers of plastic. So our windshield saw needs to penetrate through actually 2 plastic layers and 2 glass layers all at the same time. Our patient concerns that we're going to have to consider before we commit to using either one of the windshield saws would be covering the patient and the medic inside with a blanket or tarp. In addition, holding a board of some sort up underneath, KED or a long board, to try to insulate them in case the saw blade would slip and get further, closer to them, further away from us. So we need to put those safety precautions in effect. In addition, the vehicle has been stabilized, and the teams inside and outside would be ready to go. At that point, the team working with the windshield saw, this is one of them, this is the Glass Master. You would take one end of the windshield saw and make a punch hole down through the glass. Now, as you punch down through the windshield glass, both of the tools that I'm going to work with have the ability to make a good, deep punch hole. That's important on your windshield saw. At that point, then, we'll turn the tool around, and using this is significant. These are industrial blade, coarse tooth hacksaw blades or machine saw blades. And what we'll attempt to do then is penetrate down through the layers of glass and plastic. When you're using a windshield saw, this style or any style, when we go to make cuts across the bottom, we have a concern. If we continue to cut down through the windshield glass, the blades, just like the axe, will bang against the dashboard. If you were chopping it with an axe, here we're sawing it. So at that point, what we'll demonstrate is how the windshield saw can be used almost horizontally after the punch hole's been made to saw through the glass. Now here's the key. 2 firefighters utilizing 2 windshield saws of whatever type you purchase should be able to cover, coordinate, and remove the windshield in 60 seconds or less. And the windshield saw is a technology that allows us to do it safely and quickly. Let's take a look now at the actual tool in service. Now, with all protection in place, coordination with medics and patient safety, that's all taken care of. Take your windshield saw and make your initial punch hole. And you see how well the Glass Master sunk in. Pull out of that initial opening, and now I'm going to, with my hand behind this particular grip, going to insert the saw blade and begin a sawing action. You can do it as fast, or you can do it as delicately as you like. You can make the depth, do short little cuts, or deep, aggressive cuts. One entire side needs to be done. A partner would work the opposite side, and then what each firefighter would do is, after they've done their vertical, they would step out or reach out towards the center, make again their initial opening, and then do the windshield saw action towards them. All right, the bottom cut, or a punch hole has been made. The bottom cut is horizontal. My purpose here is coming to the point where my 2 corners complete. In the time it took me to make my vertical and half the horizontal, my partner with a second saw should have been able to make their vertical, their horizontal, so we would in essence be able to lift the windshield. Let me show you. this point then, when the firefighters utilizing their windshield saws have completed vertical cuts and the low cut across the dash, it's appropriate at that point then for the two firefighter team to simply lift the windshield glass, flip it back onto the roof, and at this point, if the windshield needs to be sawed again, it could be. Here I have a little of the mastic that's sticking. I can reach out, I could saw if there's any more bonding. Here's a good example of a little bit of the lamination still holding. I flipped the glass, the windshield completely clean. The firefighter team would walk it to the back of the car, off the back end of the car, and stash it underneath. Again, two firefighters, two windshield saws, no more than 60 seconds, the job is done. Let me show you one more feature that our windshield saws of today have. I'm going to come around to the driver's side. We're going to talk about side tempered glass removal. Now, one of the final selling points why you may want to consider upgrading to windshield saws is all of the windshield saws come with a feature that a firefighter can also break side and rear, which is our tempered glass. Here's, again, the Glassmaster windshield saw in the handle has a hollow tube that fits a spring-loaded center punch. And literally, the spring-loaded center punch can be stored this way or readied by instantly putting it in position. Now, once again, if it's safe to do so, medics have been protected, patient has been protected, and they're ready, the firefighter could simply come to the tempered glass window with their hands on the tool. What we wind up with is an all-in-one glass removal tool. Here's one of the competitors. This is the second windshield saw. This is Quick Cut by the Howe Company in Ohio. This again has the industrial blade. You can put the teeth in facing either way to push or pull the glass. It has an adjustment for depth, so the blade can be longer or smaller. And also, if you look closely, at the very end, it has a small solid steel pin, which in essence is sharp and hardened enough that it, if pushed against side windows, it in itself can be a glass side window or rear window removal. That's the new technology of windshield saws. We have two good examples of what's state-of-the-art out there. The Glassmaster Ware Engineering in Indiana and the Quick Cut Howe Company in Ohio. For more information on either the Glassmaster or the Quick Cut tool, contact the manufacturers themselves. Glassmaster is made by Ware Engineering. The phone number is 1-800-457-GLAS. Now, for more information on the Quick Cut windshield saw, contact the Howe Company at 1-800-228-7612.
Now, for those of you earning college credit by watching American Heat, it's time for this month's college questions with Dr. Bill Kramer of the University of Cincinnati. Bill?
Thanks, Larry. Hello and welcome again to our college segment for American Heat. It's a brand new year, and maybe this is the year you promised yourself you'd get involved in your own fire science education. And this is a great way to do it. With American Heat, there is no final exam, there is no textbook. You simply provide written responses to the 5 questions each month, and each and every month you're given 1 additional credit hour toward your fire science degree. With that, let's go with our questions this time. Number 1, what single idea do you have for government officials in Southern California that would help them prevent their ever-recurring deadly wildfires? Number 2, explain how Joint Command was used in the Southern California fires to coordinate the efforts of numerous separate agencies. Number 3, what lessons were learned regarding the use of the media, media relations, and media safety in the Southern California fires? Number 4, provide a critique of the fire and rescue operations at the deadly Amtrak derailment in Mobile, Alabama. And number 5, what can be done to help prevent Amtrak accidents, such as the one in Mobile, from happening in the future? That concludes our questions this time. We look forward to your responses and wish you the very best for the coming new year. For American Heat, I'm Bill Kramer at the University of Cincinnati.
Thank you, Bill. Coming up in just a moment, it's everything you've always wanted to know about personal protective clothing on survival training, right after this.
If you're subscribing to American Heat, you're only getting half the picture. For the rest of the picture, you need the Fire and Emergency Television Network. FETN provides the latest breaking events and up-to-date training in the most immediate method available today, satellite broadcasting. As an FETN subscriber, your department can receive award-winning programming on a daily basis. Programs such as Turnout, covering the latest fire, rescue, and emergency headlines, new legislation, and new products. Hands-on training, concentrating on specific training topics in a hands-on manner. EMED, with training specifically designed for emergency medical services. And IFSTA, bringing the manuals of the International Fire Service Training Association to television. Best of all, FETN can significantly reduce your liability. All your training will be documented automatically when you enroll in the FETN Academy, a service offered free with your subscription. For more details, contact your regional sales manager. Tell them you want FETN in addition to American Heat, and they will take care of the rest. American Heat and FETN for all your training needs.
Welcome back to our program. As always, we're joined by American Heat's Director of Training, Ron Moore. And Ron, we want to talk about protective clothing.
Okay, on this month's edition, Survival Training will be starting the first of our series to last throughout all of 1994 on basic firefighter training skills or information that's important to those in the fire service for training. And to keep it basic and keep it simple, we've started this month with the structural clothing story. We went to Cairns Brothers, manufacturers of protective clothing in Clifton, New Jersey. And we're going to go through their manufacturing process where they're going to tell us how to take a fire coat, no matter what brand, and how to look and show where it complies or does not comply with applicable standards. And there's a very interesting slant onto why some of the features that are on our structural fire gear is truly there. There's a reason behind storm flaps and collar buttons and snaps and the like. There's a reason behind everything. So let's take a look at our first section for 1994 on survival training on our protective clothing.
NFPA requires a certain specific amount of design requirements. First thing is they require an outer shell, moisture barrier, and a thermal barrier. They can be attached or they can be separate. There's some new liners that are coming out right now that the moisture barrier and the thermal barrier are fused together, or that even all three could be fused together. They can be separate. It's important though, and they require it, that the liner has a means of fastening directly to the shell, either by snap or zipper or Velcro or any other means. The outer shell, aside from meeting specific performance requirements, which we'll talk about later, has to have a means of positive fastener closure, meaning snaps aren't just enough or Velcro isn't enough. Positive locking means that it has to have a hook and D or a zipper, something that requires some manipulation to unattach it rather than just physical force of pulling. Okay. Any pockets that are going to be there have to have two things. First of all is a means of closure. This could be a flap. Recently NFPA just changed this to any means of closure, meaning it could just be a snap or Velcro or anything like that. They also have to have a means of drainage, just for water to escape from the pocket so it just doesn't fill up and bulk out. Okay. As far as trim is concerned, there's two things to think about. There's a couple different types of trim on the market. Both of them are certified for third-party organizations. There's two different features that they ask you to look at, though. The first one is for daytime requirements. So there's a certain amount of square inches required to be on the coat of fluorescent color. It could be yellow, it could be orange. any fluorescent color. Okay. Second thing is for CIL, which is like a luminous intensity scale, I guess. This basically says that it's the reflective quality at night. Okay. As for the design and attachment of the trim, there has to be a full circumferential band around the wrist, around each wrist, and a full circumferential band around the bottom of the coat. This can't be disturbed by pockets, radio pockets, anything else. Okay? A couple years ago, a lot of the manufacturers were misinterpreting the standard to such a point that pockets were going over this circumferential band and therefore breaking the standard. The top circumferential band, which you'll find on a lot of coats, can be disturbed by pockets. It's just the bottom and the sleeves. Okay? When you open the coat up, first thing you want to look at is the collar. Okay? Collar is required by NFPA to be 4 inches high in height. It can be higher, but minimum in the back and the front is 4 inches. It's also really important to pay attention to the fact that the moisture barrier that's required to be inside the collar is not broken by seams. This specific color has sewn seams in here, but you'll notice the seams don't get sewn all the way to the outside. Okay? Just like this Velcro is sewn on, and if I was to turn this in and see the Velcro stitching all the way through, we know this wasn't NFPA compliant because water could leak directly through the collar. As far as the liner is concerned, the liner has to be attached to the shell. It's required to reach all the way up to the next seam, meaning it can't stop an inch below. Occasionally, some liners snap in. If those liners are drooping below the snaps, they're non-NFPA compliant. And the liner also has to come within 3 inches of the bottom. If it's 4 inches away from the bottom hem, it's non-compliant. Okay? As far as labeling is concerned, there's a couple things always to look for. First one is a certification label. This is brand new this year. Okay? This one specific third-party certification organization isn't the only one, but it has to have a certification label, meaning it passes NFPA. It's been tested by a third party, okay? And there's always a certification number on there where if you ever had a question, you can not only call the manufacturer, but you could call the third-party certification organization and ask questions about it. Second one is this specific warning label. This text was written in NFPA. It specifies everything from do not use chlorine bleach when washing the coat or pant to this has to be worn with all the other protective clothing. Okay? And this also says that it does meet NFPA, which means that it has been third-party tested. The third label, which has to be there, identifies the manufacturer, the contents of the liner, the contents of the shell, the size, the date of manufacture, so it can be all traced back to one specific date, and care instructions. This was a Nomex coat that I went through this with. This is a PBI coat, same liner. This specific liner is a breathable moisture barrier. There's no requirement in NFPA whether it has to be breathable or whether it doesn't have to be breathable. Specifically what the liner is made out of, whether it be all the different brands of all the different thermal liners that are coming out. It just has to pass all the testing requirements for vertical flammability, water absorption, everything like that, okay? This one is a PBI coat. This has to pass the same requirements. PBI is going to pass those tests in a different way, but as far as the design requirements, they're all exactly the same, whether it's PBI or Nomex or any of the other fabrics that are coming out right now. As far as bunker pants are concerned, whether they be PBI or Nomex or any of the shell or liner fabrics available, they have to meet also a certain number of additional NFPA requirements. As far as anybody is concerned, pockets and knee pads or any extra accessories, whether they be back pockets or anything like that, that is not required by NFPA. Those are just accessories. If you're going to have pockets, though, the pockets have to have, just like the coats, a means of closure, okay? This doesn't have to be a pocket flap, which was required about a year ago. It could be just a regular Velcro or a snap, or even what you're seeing on a lot of the mic pockets now, which are just like a 1-inch tab coming down and snapping on top of the radios or the mics, okay? As far as the trim is concerned, it's much like the coat. You're required to have a circumferential band all the way around the ankle. That is really the only trim required on the pants. Sometimes you'll see more, but that's in excess of the standard, okay? The liner is required to come all the way up to the waist area of the pant, okay? It doesn't have to come all the way up to the very top, but this is where your TPP protection will stop. And this is considered the end of the pant.
We're in the quality control lab at Cairns & Brother. This is where we do all of the testing of our incoming materials before we accept anything into stock. It's very important to us that we verify the performance of all of our raw materials before we ever put them together into any kind of a product. The test apparatus that is behind me here is a TPP, or Thermal Protective Performance Tester. It's a piece of equipment that essentially measures the amount of time it takes, the volume of heat that you see here, to penetrate through a protective garment and produce a second-degree burn on the skin. Now, in fancy test terms, the heat load is 2 calories per square centimeter per second. In real terms, we're looking at temperatures in the range of approximately 1,500 to 1,700 degrees. Our heat source is comprised of 9 quartz radiant heaters and 2 propane-fueled Meeker burners. Now, this is a water-cooled shutter which completely blocks the heat from reaching the sample before I'm ready to start the test. So I can safely swing this into position and not affect my readout. Now I press my start button, it retracts the shutter, and now I'm getting direct flame contact, and all of that heat is coming up and burning away the outer layer and penetrating through the thermal barrier and trying to reach the skin. Okay, this is carbonized Nomex on the outer surface, and you can see it's really all flaked away. It's gone. Some of it has attached itself to the moisture barrier. You can see since the moisture barrier is also mounted onto Nomex, this Nomex layer is also carbonized. We get into the thermal barrier, which is your real insulation on the turnout clothing, and the surface closest to the flame shows signs of heat damage. Now, we don't have the heavy carbonization. This is still flexible, okay? The side against the skin, you can see the heat damage on the face cloth. Now, the discoloration in the face cloth is primarily due to the dye, or the color in the face cloth, burning off. That will begin to occur when the material temperature reaches 400 degrees Fahrenheit. And the higher the temperature above 400 degrees determines the degree of degradation of the color of the face cloth. Now we're going to use the same thermal barrier material, which is 100% Nomex, the same moisture barrier, which is Gore-Tex on Nomex, but we're going to change the outer shell material. This is a 7.5 ounce ripstop PBI Kevlar blend. Now, the PBI Kevlar is the same weight per yard. The 7.5 ounce means if you were to cut 1 square yard exactly of the material and weigh it, it would be 7.5 ounces. So the overall weight of the Nomex and the PBI Kevlar are the same. Now, here's the real advantage to PBI Kevlar, is you don't have the carbonization and the embrittlement of the PBI Kevlar that you had with the Nomex. You've still got something left. Your outer shell still has integrity. Now, this is actually carbonized or burned PVI Kevlar. And the way that you know that it's been burned is because it has lost a lot of its strength or integrity, although it's still intact and flexible. But if you pull on it, you can see that it will now rip, where a piece of unburned PVI Kevlar absolutely cannot be torn with the hand. But overall, it does have better structural properties under heat conditions than the same weight of Nomex.
The protective ensemble a firefighter normally wears includes his gloves, which are NFPA compliant gloves that have a thermal lining in them and a moisture barrier. And then we start from head to toe as far as the protective ensemble. You can see that when he's in a firefighting situation, if you just turn a little bit this way, there is no breach anywhere in the system. With his gloves on, there would be no breach anywhere in the system where the heat or flame could get to him. That's deliberately intended that way to keep the firefighter completely protected in case of the worst possible environment, which is a thermal inversion or a flashover or extremely high heat rush of hot air that can sometimes happen without a flashover condition. The helmet has several components that are critical and required by the minimum standard. It has an outer shell, it has a impact liner, which is the gray impact insert that's inside here, and it has a head-mounting suspension system on the inside that is comprised by the overhead strap, which is a crisscross strap that goes, and the cushion lining with a ratchet. Now, the ratchet mechanism is currently optional, but most manufacturers are switching over to it because it provides a substantial amount of increased stability on the head where the chin strap doesn't become so critical to the firefighter. Chin strap is still absolutely has to be worn in a firefighting environment in order to get the intended protection from the helmet. So there's no reason not to use the chin strap, but you get better stability when you're running, jumping, extending, bending over with the ratchet in place as well as the chin strap. The helmet has to survive 5 impacts and still sustain the kind of impact through to your head that's low enough for a head or a human being to survive 5 times in each of 4 different conditions. The room ambient conditions, which is the test lab room ambient of about 75 degrees, as well as wet, cold, and hot. When we test the helmet for heat, we actually expose the area that's going to be targeted, and you'll see this in a minute, with a high degree of radiant and convected heat before we hit it, so that the area that's being impacted is deliberately attacked by heat, and then we do the test. The helmet also is tested for its thermal stability by putting it in an oven intact on a head form, and when it comes out, it can't have drooped or flowed material anywhere. So that's the headgear. Next on the way down the firefighter is his hood. In the new 1991 standard of NFPA 1971 for protective clothing, the hood is given its own new chapter. It's under accessories, and all the criteria that are required by a hood are included now in 1971. 1500 has now recognized the need for hood by recognizing 1971 and protective clothing. So without really even saying it, 1500 and 1971 make it a mandatory requirement now, if you're going to be compliant with 1500, to have hoods in service. It's an interesting twist that we just sort of picked up on recently. You take the BA off now. And the breathing apparatus is also compliant with NFPA 1981, the breathing apparatus standard. Can be either low pressure or high pressure, has to have a certain amount of duration, can't weigh a certain weight. The breathing apparatus can't weigh more than 35 pounds. In the new standard, which is about to be promulgated, there'll be a heat and flame test, which actually takes the breathing apparatus on a mannequin through a test situation that involves a 200-degree heat up and then a flashover condition. And nothing on the breathing apparatus can burn after it's exposed to that for more than 2 seconds. Very tough test. The coat and the trouser are next, and one of the important things that we'll be looking at, you can open it up, in the new standards as they come out, is the overlap between the coat and the trouser. The coat liner has got to extend, according to the NFPA criteria right now, they're currently in force, 5 inches from the bottom of the thermal lining to the top of that thermal lining. And that's done by the 1500 standard saying that there has to be an 8-inch overlap, and the NFPA 1971 standard for the clothing, saying that this liner has got to come within 3 inches of the bottom of the hem of the coat, and the pant overlap, the coat overlap's got to be 8 inches, so 3 less 8 equals 5. Under the new conditions, when we button this guy up and he raises his arms up and bends around, okay, to extend the coat, the overlap can't be more than 2 inches, can't be less than 2 inches. So there are a lot of things that you need to know about specifying fire gear that we can't possibly cover in a short presentation like this. Things like how well the gear fits on your body. Actually putting together a group of 5 fit testers and evaluating the fit of each of the garments that are submitted to you by manufacturers is an excellent way to get a feel for how well the garment is balanced on your body. If the garment's cut right, there won't be any binding through your shoulders when you stand naturally and in a relaxed position with the garment laying on top of you. There won't be a feeling of an imbalance anywhere in the garment. It typically occurs across the back of the shoulders if it's not properly cut or designed. The arms should have a natural bend to them so that you're not fighting a tube that's cut straight to come forward when you want to move your arms. The bellow underneath the jacket has got to be large enough so that the jacket doesn't rise all the way up when you raise your arms. That bellow action in there actually provides an accordion fold so that it works for you instead of against you when you're in a firefighting situation. When you evaluate the coats, go through natural firefighter motions. Don't do weird things that you'd never actually do in a fireground. Do natural things. Extend yourself. Raise your arms the way you would if you were extending a ladder or swinging an axe. Those kinds of things will tell you whether or not the garment fits right. If the garment's well outfitted for you, it'll also be easy to don, easy to doff, and comfortable to wear. Easy donning has to do with large Velcro surfaces on collars, so when the collar is raised and the closure takes place, you don't have to worry about where it catches on the landing. The surfaces are large, and no matter whether you get a good grip or a lousy grip, it'll still hold on. Small patches in this area are typically underspecified garments. The front closure system has got to be well overlapped so that the thermal lining material from one side overlaps the thermal lining material on the other side. And the moisture barrier should have, the storm flap should have a moisture barrier in it to complete the overlap protection so that no moisture can penetrate from the exterior to the interior. So an overlap that actually extends the moisture barrier and lining system all the way up next to each other, which this one does when it's lined up, is a good specification, and you need to think about those things because they're not in the NFPA minimum criteria. Padding on the knees and the elbows can be a good idea, and linings in the cargo pockets, whether they be on the pant or on the coat, that are actually lined both outside and inside, so that if any sharp protruding object is carried in your pocket, it doesn't penetrate to the interior and give you discomfort, as well as harbor good maintenance on the outside of the garment. This is a very often abraded surface, particularly when a firefighter is on his belly crawling across the floor. And then the final configuration and the final message we'd like to leave with you is that the best way to build a turnout coat is from the inside out. If your department is dealing with the reality of budgetary restriction and you have some money to spend on gear, but you don't have a lot of money to spend on state-of-the-art gear, start from the inside out. Your body is the most important factor in this. Get yourself minimum NFPA protection, which is what this ensemble basically represents, a Nomex outer shell, a moisture barrier that's qualified to the NFPA criteria, and a thermal lining that's qualified to the NFPA criteria. Those are your basics.
Best thing is put a washing machine right in the firehouse. Get yourself a good, heavy-duty, large-capacity washing machine. Do it right in the firehouse. Maintain the contamination in as small an area as you can. Don't spread the trail of contamination out over a large area. So what you want to do to wash this stuff is you want to separate the shell from the liner. Now in the cuffs on these coats are little tabs that snap the liner to the shell. You just want to unsnap them and pull the liner out. Now, the shell, you can wash the shell right in your washing machine. You can put, if you've got a large capacity, say an 18-gallon washing machine, you can put 3, maybe 4 of these in at a time. Use warm or cold water temperature. Use any good laundry detergent. We've had good success with Era. We've had good success here with heavy-duty Arm & Hammer. Any of the good laundry detergents will work well on it. Make sure you get a washing machine that has a delicate or gentle cycle on it. Now, if you've got real heavy contamination on the shell, you can get it off by going to permanent press or a sturdy setting. But you don't want to do that all the time, because what that's going to do is it's going to beat up the coat, it's going to agitate it like crazy, and you're going to decrease the life of that shell. So do it on a delicate setting, and you'll prolong the life of the garment. So run it through a regular wash cycle, look at it. If it's still dirty and it needs some more, run it through a second time. Best thing to do, after it finishes the spin cycle, take it out, put it on a hanger, hang it in a well-ventilated area out of direct sunlight. You can hang it in the fire station, or you can hang it outside in the shade. If you hang it in the fire station, if you set up a smoke ejector fan, get some good air circulation around it, it'll dry a lot faster. Now that's the shell. The liner. Don't put the liner in the washing machine. Okay, the liners are made basically of needle punch thermal lining material. Now what this is these are fibers of material that get laid out in a bat, and then all of these needles come through and punch through it, and it locks the fibers into each other, and you end up with this very consistent batting. Then you take that batting and you sew it to a face cloth, and that's what really gives it its structural integrity. It won't pull apart like this. But you see, you can pull those fibers out of this. Okay, that can be forced out. If you take these liners and you put them in the washing machine and you keep agitating and agitating them, that's what it's going to do to the liner. It's going to start pulling it apart like this. You don't want to do that. Best way to do a liner is you take it out of the coat, take and turn it inside out. Because the liner, this isn't the part that's going to be the dirtiest. You're going to sweat like a crazy in the liner. You got sweat contamination in here. It's going to smell. You want to get rid of that. So turn it out so that the dirtiest areas are what's exposed. Then you take it and you hand wash it. You put it in a sink or get a big tub. Fill up a big tub with water. Again, use your detergents, put some detergent in, and hand wash it. Just keep squeezing it in there. Let it soak for a while. Let that detergent get in. Squeeze it some more. And take it out of there. Go into another clean tub with fresh, clean water. Rinse it out. Go to another tub with clean water. Rinse it again. When you don't see any more suds coming out of it, then just take it and don't wring it like this, because you'll break those fibers down. You just gently squeeze all of the excess water out of it, get as much water out as you can, and then again, just like the shell, you hang it up, you let it drip dry, get the smoke ejector fan, blow some air on the thing, get it dried out. Don't hang it in the direct sun. Now, care and maintenance of a helmet. Helmets are a little bit easier than your protective clothing because there's a little bit less to deal with on the helmet. Basically, the outer shell, you just want to wash it down with a good soapy water solution. Just take a rag or a sponge and wash it down on the outside, rinse it off well. You got to be careful that you know what the helmet shell material is, because if you're working with any of the thermoplastic helmets, the PPCs, you don't want to use any chemicals at all on a PPC shell, because you'll definitely degrade the material. The inside of the helmet, again, you can just wash it out with a soapy water solution, get whatever debris is out of there, wash the liner again, and then set it out to dry. Now, how do you know when your gear has taken too much? How do you know when you've actually damaged it and it's not going to do what it was supposed to do for you any longer? Well, here's a good example of a Nomex coat that's been damaged in an actual fire. Now, you can see the reflective trim is melted away. Ordinarily, the trim, that's a maintenance item. This can be cleaned up, and the trim can be replaced. If all I had was this trim damage, I could replace that trim and get this coat back in service. The key things to look for on this coat are, you notice the Nomex has different shades of brown. You've got a light brown area in here that goes into a dark brown, and in this crease here, the material is very stiff and is very brown. Okay? This is that area of damage to Nomex that is between 700 degrees and 750 degrees. When Nomex starts turning brown and starts getting stiff, it means that the material itself has been heated to at least 700 degrees. It's less than 752 degrees because you don't have that embrittlement and the carbonization of the Nomex. But this dark brown area here is severely degraded Nomex, and I would take this coat out of service. Now, if it was limited to just one arm, then you could replace just that one arm of the coat and put it back in service. But when you've got a large area of different portions of the coat, you probably would want to take it out of service and replace it. When you see this condition on the outer shell, the first thing you want to do is you want to pull the sleeve out, and you want to see what your thermal barrier looks like, or your liner. Now you can see this liner has taken just as much heat as the outer shell has. So this liner is done too. Now the important thing to note on this particular coat is you get through to the inside where it was next to the skin, and you have nothing on the inside. This coat did what it was supposed to do. It protected the firefighter.
Now again, Larry, the importance of this is the firefighters have been given a very expensive piece of equipment. Protective clothing from head to toe can amount to a substantial dollar investment. And what we're trying to do with this training segment is to give you, the firefighter, the ammunition to keep that gear working for you. It is, in essence, one of your best lines of defense against preventing burn injuries and the like. So knowing how to keep the stuff working for you is the other side of the story. Very important stuff. We also want to mention, Larry, the training segment number for this particular segment. It's 5010013. That's this particular edition, the training segment on protective clothing.
And the danger, I guess, is that a firefighter might take that gear for granted, and he or she just can't afford to do that.
Yes, and the investment has been made. It's the firefighter's responsibility to keep the maintenance so it continues to work.
All right, Ron, thank you very much. Well, that's our program for this month. On behalf of all of us here at American Heat, we want to wish each and every one of you a very safe and healthy new year. Thank you for joining us.
And remember, next time we may be watching you on American Heat. Bye-bye.